Okay, thanks for the introduction here. I'll plan some little demos during the talk. We had a little laptop issues. I'm not sure if you came in late, you probably didn't see that. I managed to blue screen the laptop during the test. So I'll do the demos at the end, but just to make sure I don't crash anything during the talk. Anyway, let me just quick introduction of myself. My name is Johannes Ullrich, and I work for the SANS Technology Institute as Dean of Research, so I'm responsible for the research activities at SANS. Personal interests are, of course, web application securities. I see myself as a developer more as a pen tester than as a pen tester or a sort of attacker, so really more as a defender and builder, which is sort of why this track works actually pretty nice here. I'm in charge of the SANS and Storm Center, which is sort of where SANS houses some of its research activities, and we monitor some threats there. DShield.org was sort of what evolved the Internet Storm Center, and in part sort of one of my first big web apps that I sort of created from scratch, like something like 13 years ago, and where I sort of learned how to defend web apps also somewhat. I live in Jacksonville, Florida, officially Florida, but anybody ever been to Jacksonville? It's really more southern Georgia. Yeah. But anyway, and my education is in physics, and like I said, I've worked as a web developer. Grew up in Germany, so that's where the accent comes from. It's not a Jacksonville accent, but anyway. So what's HTML5? First, I'm going to start out with a couple of definitions here before we do an official sort of outline of what I'm going to talk about. And as I put it here, well, collection of JavaScript APIs that sometimes actually work. That's in part the security challenge too, and we'll talk a little about that. I mean, we try to harness some of these APIs. The problem, in part, also from a security point of view, is it's not as much the web application sometimes that gets in trouble with HTML5. It's the browser. And one of the classes I teach for SANS is our Defending Web Apps class. And when I tell people, the first thing there is, you don't control the browser as a developer. And that, of course, really gets to bite you some of this HTML5. And yes, you're a security-aware developer. You browse with links because you don't trust any other browser. Doesn't mean that your users use it. So that cross-site scripting vulnerability that may not really affect you will still affect your users because their browsers support HTML5. So in many ways, you're exposed to HTML5 in your applications, no matter whether or not you take advantage of it. So why not use it? Why not try to do something useful with it? So anyway, what I'll talk about is some ideas, and certainly more fragments here, and I'll show you some code and such about what you can do with HTML5. And of course, one of the focuses of HTML5 is mobile applications. So mobile, more interactive applications. Maybe we can do something about mobile authentication with HTML5. How do you authenticate to a mobile web app? Username and password, probably just like your desktop app. Do passwords work for desktop web apps? No. Do they work with a little keypad that you can't really type on? Even less. So some of these challenges, maybe we can help a little bit with HTML5 here. When we talk about authentication, I also want to make clear that earlier the gentleman, if you listen to their talk, they were talking about medical devices. I have a neighbor who's a nurse, and she sort of has a little bit of different story when it comes to medical security. In the operating room, they have a special cabinet that houses the dangerous medications, like the addictive stuff. In order to open it, she needs a smart card. So she swipes the smart card, opens the cabinet, until the authentication server crashed. And that cabinet didn't open. Sometimes too much security can actually be dangerous. And just when it comes to authentication, sometimes you just want to exclude a certain group of people. So you rather allow access to someone who shouldn't have access in order to maintain the availability of the environment. Same with adding additional features to authentication. They may individually not be strong enough to serve as an authentication feature. Think about IP addresses. IP addresses are not supposed to be used for authentication. CSRF and all of that good stuff. But as an additional factor, After you gave me a username and password, why not restricting administrators from only connecting from inside our network? So this sort of this inclusive, exclusive authentication factors are things we use to throw people out. But they're by themselves are not individually strong enough to serve for authentication. And with this, a little segue here about multi-factor, because I see that's used a lot badly. These locks here. Is this two-factor? It has a fingerprint scanner. It has a keypad. Ooh, 4 buttons. I call this half factor because it's either the keypad or the fingerprint. So I attack whichever factor is easier to attack and get the safe open that way. So be a little bit careful with that now. So we have got this 1.5 factor. I'll come back to that. Where the second factor is like a cookie that you store in the system. I say 1.5 factor, not 2 factor, but it's still better maybe than 1 factor. So here's some of the HTML5 features that I picked on, so to speak. I picked them in part because many of them, like for example, local storage, are actually pretty well supported. Others I picked, like for example, the media capture APIs, because there's some real cool potential in there, but really nobody supports it very well at this point. So maybe a little bit more future outlook here. So anyway, let's start with local storage and session storage. That's sort of something new when it comes to web applications. Traditional web applications, you had very little ability to actually store data on the browser. Now, if you're a security guy, that is probably a good thing. We don't really want to store too much data on the browser. But now with local and session storage, we have the ability to store megabytes on the browser and abuse that. The one thing that's really different and gives us a different capability that we didn't have before is of the session storage. We had cookies. That was sort of not the best kind of local storage we had available before this came around. Cookies are global to the browser. Session storage, the scope of session storage is limited to the window or the tab. As soon as this window is closed, that storage is gone. Local storage is the opposite. It never really goes away. It just stays there until you explicitly delete it from your application. So could we use something like this for like a 1.5 factor authentication? Something better than a cookie. A lot of the times, this sort of 1.5 factor authentication is implemented with Flash cookies. Now, Steve Jobs told us Flash is dead, so we probably should use HTML5 and local storage for it now. Last time I checked, Steve Jobs was dead and Flash was still around. But anyway, so there's this concept of this ever cookie people throw around, where you basically put the same data into multiple locations. Can be used for good and evil. But the idea is we identify the device. Once the user logs in, we store this cookie on the device. When the user comes back from a different device, we can detect that. We can require a more strict authentication and do a little bit more, raising the bar. Okay, problem with cookies. We had a couple simple methods to prevent common attacks. Cookies leak over HTTP. So we have the secure property. Secure property tells us, hey, only send this cookie over SSL. And we had HTTP only. Every website has cross-site scripting, in my opinion. I know mine has sometimes. But one attack with cross-site scripting is steal cookies. This HTTP only, well, perfect, but pretty good. We no longer have this in local storage. The only way we are going to get access to that data is via JavaScript. So you have to keep that in mind. A couple other things. CSRF, cross-site request forging. Why does it work? Well, it works because your browser sends that session cookie with every request. If you keep your session cookie, or the session information, I should better say, the session token, in local or even session storage, it's not going to be sent unless explicitly send it from JavaScript within the page. So yeah, real nice defense here against CSRF. And the other thing, users logging out. Anybody here ever checked how many of your users actually click the logout button, other than the auditor who tests that it works? I've seen tests with like financial websites that were in the 10% range. Now, okay, a proper implemented session cookie goes away if the browser is closed. But the browser is never closed, it only crashes, and then you have to restart it once in a while. So with session storage, that goes away when the user closes that tab or that window. So that's a little bit more likely to happen and gives you a little bit more security. Now, risks, like I mentioned, no way to enforce this goes over SSL. It's up to your developers. And if your developers are like me, you better double check that this actually happens. And then no way to protect this from JavaScript. Well, that's how you get to it. The only security model here you have is same origin. And well, there are many sort of issues with same origin that DNS pinning and attacks like this, that as a developer you may not necessarily have full control over once the data is at the client. And then the fundamental problem with local storage is sending too much data to the client. Now you may say, hey, I authenticate my user. My user is authenticated. I don't fall for the second bullet here, where I push the complete database to the client and then let the client do the authentication. But even if you just push the data that the user is authenticated for, you ever lost your phone? I lost mine like last year, brand new iPhone 5. I hope no web application pushed too much data to it, because once the phone is gone, that data is gone. Plus, it's now accessible also to cross-site scripting attacks and same origin bypass and all of that good stuff. So you have to be careful with this. Is it supported? This site, I will use it a couple times during this talk, caniuse.com. Like I said, local storage, session storage, very well supported in different browsers. Opera Mini, but if you are doing HTML5, don't support Opera Mini. That's the one browser has real issues with that. I keep hearing it's fairly popular. I don't really see it in my logs, so I don't know what your users are using for browsers. In my opinion, for something to sort of work and be useful in the mobile world, iOS, Safari, and Android have to support it, Chrome. And then it sort of becomes useful. If only one of them supports it, it's probably not all that useful. Anyway, so local storage is pretty straightforward. There's another neat feature that you probably don't associate at first with security, and that's the canvas in HTML5. The canvas allows you to draw on the browser. And here's one application. I forgot to put the URL here where I got the image, but sort of a little demo application, a first-person shooter game running just in the browser. So really detailed, fancy pictures you can draw here. How can we use that for security? What about a more interactive graphical login? I talked about the problem with mobile authentication. How are you going to log in while driving in your car, one hand on the phone, the other holding your coffee, and now you're trying to log in? Yeah? So these patterns are sort of one idea. This is the Microsoft implementation. Microsoft started doing that in Windows 8, I believe, is when they started introducing that in parts of the tablet push. Android, of course, has sort of this little connect the dots game. This is a good one. Let me just go back here. One problem with these graphical authentications, they sound good when you hear about it. Hey, I can draw all kinds of pictures on it, lots of variability. Recently, I read a paper where someone actually did some user testing on the Microsoft version. And hey, everybody circles the faces. And dots the eyes and such, or draws little smileys over the faces. This sort of is a good one, but who has Android phones here? Is your pattern as complex as the one here? Probably not. It's usually like a C or something like that. Haven't seen any good testing yet for the Android pattern, but I would expect that they're not really all that diverse as they could be. So anyway, this is the demo I'm going to do later at the end of the talk. But anyway, here's a little URL you can take down now. I'll repeat it later. where I sort of put up a couple demos, like here's sort of a little Canvas JavaScript thing where you can log in, or right now to sign up using sort of a pattern like this for a mobile device. Right now it's just with the mouse, and there's a GitHub repository for it. Again, is it supported? Yep, pretty much everywhere. Even Opera Mini sort of supports a little bit. So the Canvas feature is pretty well supported. It's not terribly easy to code for it. In particular, if you want to have it work across devices like coordinate systems and such, you have to be a little bit careful there. The demo I set up, I sort of did sort of plain JavaScript. You're probably better off using something like jQuery or such, and that build some wrappers around it and makes it a little bit easier to use. Anyway, mobile devices. Now, all of those taking pictures here. There's one thing that's being added to those pictures, and that's the coordinates of where the picture was taken. Now, pretty much all mobile devices now have some form of geolocation ability, whether it's a GPS, whether it's based on Wi-Fi or cell phone towers. Some of them are pretty good. Of course, they can be spoofed easily, so you can't use it as an inclusive authentication method, but why not use it as an additional authentication method? If you want to transfer $10,000 from your account and you're currently located in Russia, maybe we shouldn't really allow that. So those are some of the decisions where this can help. In particular, again, on a mobile device where you may have had some shortcuts to authenticate to make your app usable on this local device. So on the other hand, it's really only useful for mobile devices. There's some geolocation. It's just by IP address, for example, for desktops. I find it usually doesn't work all that well. If it's based on whois lookups and such, then you may get the location of your ISP, not necessarily your home location and such. With mobile devices and Wi-Fi networks, it usually works actually pretty well. So other things you can look at is to avoid some spoofing, sudden changes in location. Why did you all of a sudden just jump 100 miles? So doing some other more advanced browser fingerprinting. I'll talk later about. You can also get the tilt sensors and such to make spoofing harder. Doesn't make it impossible. So again, pretty well supported actually, other than Opera Mini. So anyway, like I said, geolocation, nice feature, nice additional authentication, but nothing you can really sort of exclusively rely on. Now these days, everybody wants to do biometrics. Take my fingerprint and run with it. Now, or your face. And we start seeing now this stream API that's being added to HTML5. Chrome supported very well. Not sure if you've seen it, sort of video conferencing just via HTML5. Real nice applications you can build there. But is it good enough to do actual biometrics, not just a gimmick? Again, Android does sort of implement the face recognition as a login. In my testing, not really all that great. The problem you're running into is a lot of variabilities in lighting, for example, in particular on a mobile system. Who knows where you use it? Try to use it at night and log in. That's pretty hard. How far away do you hold it? That matters a lot. You can't just look, for example, at the distance of the eyes. Now, that changes depending on how close you are to the device. But what you have to look at is you have to measure sort of the relative angles and relative distances, the ratios between different facial features, and that's not really all that accurate. So really, instead of thinking that you have like thousands or tens of thousands possible combinations here, you really only have about 100 different faces, so to speak, that you could recognize using this feature. Fingerprint, Apple, of course, made a big splash here with their fingerprint sensor, a pretty high quality fingerprint sensor. But first of all, they don't give you access to it via some kind of API. And second, even that's spoofable. So it may be that fingerprint sensor may be good enough compared to a password and other kinds of authentication. At least as a second factor, it may be good enough. But that's sort of very high end, nothing you typically find in a device. Here, this is sort of a little face detection API that someone wrote, and it sort of draws these classes over your face. So this is all done client-side in JavaScript. So you can do facial recognition in JavaScript on the client. And the reason you do this on the client is, so you just send the coordinates to the server, and that's how you authenticate. You don't authenticate by sending the picture of yourself, you authenticate by sending the coordinates. And that way you get better performance, you also don't have to store the entire image. So that's kind of how you do it. And it's possible, but like I said, even in this little demo they set up here, the resolution of the system is not really all that great. So it keeps walking around quite a bit over your face. So really hard to get a decent sensor to do this. The built-in cameras you have in mobile devices are not really sufficient. One thing I played around with was, what if you just hold your thumb against your camera? The reason I sort of got that idea, there's like on the iPhone, Android probably has a little app that measures your pulse. You basically just hold the thumb against the camera, and then you turn on the flash. So your thumb is kind of lit up, and the blood vessels become somewhat visible. It doesn't really work. Like whenever I acquire an image like this, all I get is sort of a big red blob. Yes, you see some color variations sort of with the blood pulsing, but your pulse is probably not constant enough. You can use it as a sort of identifier of yourself, and it also doesn't vary that much. So from person to person. So anyway, this doesn't work yet. As a gimmick, yes, but that's about it. Hand signals, like with the camera, I could sort of like sign instead of type. That can work. At this point, the client-side software isn't there to sort of analyze that. And live streaming the video to analyze on the server, I don't think that's sort of quite feasible, in particular if you think a mobile device with limited bandwidth and such, that may not really lend itself too much to do this. But anyway, is it supported? Like I said, this is a feature that has a lot of potential if they get the cameras worked out and such, but right now it's really only supported in Firefox and Chrome. So these are the only browsers that really fully support this feature. And even there, I haven't seen a lot of stable, I should say, applications that sort of use this feature at this point. It's still very much under development. iOS started a little bit of this. You can like upload images from the camera and such, but more still shots, so no live streaming video or anything like that. Anyway, so what other features do we have? I mentioned the accelerometer. What about instead of typing on the phone, you just sort of move it in a pattern, which again is sort of fun in the car. You hit someone next to you or so, sitting next to you. Can work. I tried it. I tried to write some code for it. You can definitely detect it. The problem is sort of making sense of it. There's a lot of noise and a lot of non-reproducibility here. So you need more algorithms here to really sort of figure out, what is the letter I sort of try to write in the air here. There still needs to be some work done. That has actually, I think, a lot of potential. Because now you could sort of tilt it. I thought about like a little game where you sort of have a little ball that you sort of move in a pattern to log in. Works okay if you're at rest. Try to do that once you're driving on the subway here, sort of holding on with one arm and hanging in there, trying to move that ball the right direction. Some of the usability stuff still has to be worked out there. It can work, and I think that would make a real nice kind of project to implement that, but needs quite a bit of code to be written yet for that. There's no standard sort of library to do this. It is actually pretty supported. It is supported somewhat on Safari. They just use a different way of doing it. They don't use this API. So you can do it in Safari. And I'm not sure if you have seen any of these sort of HTML5 games, like someone wrote one with sort of a bowling ball that where you throw the phone like a bowling ball. You don't throw the phone. You better hold on to it. But so some of that software exists. It's just not out there in the open at this point that you could easily pick it up and use it. Anyway, what other newer features are there? Well, what about pop-up notifications? Now, there are two kinds of notifications that are sort of being used. There's the more standard notification. Essentially, the way this works is you still have to have the browser open, but you don't have to have that website sort of currently in focus or up, and it can send you a pop-up notification. The intent is to notify that a new email arrived. Now, Apple, in the latest version of iOS and OS X, pushed it a little bit further with their push notifications, where you can receive a notification from a web app even if your browser is closed. But this is at this point an Apple exclusive. So haven't really seen anybody else trying to sort of implement that. You need to register with Apple's sort of push notification servers to do that. Not sure if Google has anything else that's sort of similar. So anyway, why? How would we use that? Again, for security. You can use it to tell you there's a new email that just came up. But, well, why not also use that sort of like we sometimes use SMS messages? There's a pop-up, hey, someone just logged in as you from another IP address. Someone tried to log in as you, but used the wrong password. So proactively kind of notify the user of events like this. That would be one way how you can shore up your authentication a little bit to tell the user, hey, something is going wrong with your account. Do you allow that? Do you not allow that? Now, I know they always say one username, one user. You always have to allow, or not always, but many times you have to allow for some account sharing, at least you can notify the user, hey, this is what's happening. And then let the user make the wrong decision versus the application. So it's not out of band. It still use HTTP, it still use the same networks, use the same system. So it's not as good as an SMS message in that sense, if you consider SMS on a smartphone out of band. But it's better than just having sort of a message in the browser itself. Yes, it can be faked. The Apple push notifications, they're actually pretty good in that sense that the sender is authenticated. You have to sign these messages with a certificate that you receive from Apple. So the authentication is reasonably good in that case. Of course, if your user signed up for another site and allowed to send push notifications, it may not always that easy for the user to distinguish where does this message come from. So that, again, your users always get you in the end. But one-time passwords, I don't recommend it at this point to use something like this for one-time passwords. But I say, hey, let's look at it and see if it has some merit. It's like I don't like the in-band kind of nature of these notifications, but probably better than not having a one-time password versus these push notifications. You don't need to buy any equipment. You don't need to sign up for any service. It works just in your application. And that kind of what I think makes that somewhat attractive, to me at least, this particular sort of approach. So anyway, who supports it? Like I said, the Firefox, Chrome, Safari, they support it. Hey, BlackBerry supports it. IE sort of a little bit the holdout on this. I'm not sure what their exact roadmap plans are for it. I'm not sure if anybody here still has to support IE and mobile Windows devices, but some of us still do. Anyway, so I talked a lot about authentication. There's another sort of up-and-coming API for JavaScript, and that's crypto. And these days, of course, we're all concerned about privacy all of a sudden, right? Google was reading your email for years. But anyway, so one of the problems, of course, is how do you encrypt end-to-end in a web application? Most encrypted email application at this point encrypt on the server. And that way, of course, whoever owns the server owns your messages. They have the keys. Can we do more of that on the client? The other part, of course, is the famous problem of password hashing. Why are we supposed to hash our passwords? It's a big deal, right? To hash passwords. You're supposed to hash your passwords because someone could run away with your database. If someone can run away with your database, they probably can do a lot of other stuff too. Like maybe inject code before the data actually ends up in the database. Set up fake forms on your site. What you really try to protect from if you hash passwords is from someone with some form of admin privileges to your site. That's the one who has access to the database if your site is configured correctly. So if you're afraid of someone with admin privileges, why not hash the password before it even ends up at the server? And that's sort of where some of these crypto on the client kind of ideas come in. Now, like I said, this crypto API is at this point not implemented yet in any browser. It was just at the first draft here, June, that's just a couple months ago, that it was published. There are, however, a number of JavaScript libraries, and I put one in here that I think is one of the more mature ones that implement different crypto functions. Like you can do now public-private key cryptography. I could push you with the login form a public key. Or I could hash your password on the client before it's being sent to the server. So the server will never receive your clear text password. And you may say, hey, wait a moment, Johannes. Pass the hash. You're still vulnerable to pass the hash. You ever familiar with pass the hash? If I hash something and just log in using the hash, I can still log in. So you can log into my site. One of the big problems with passwords getting stolen is users share passwords. If I hash my password, and I do that different in other sites, then knowing the hash will not allow me to log into other sites. And that's where some of the big password breaches always got us, is not that your password got leaked. I know your dog is called Fluffy. But that you use the same password that you used to log into Slashdot to log into your online banking account. See, Slashdot wasn't breached, but the bulletin or whatever. Was Slashdot breached? I don't think so. But I may have lost track. So anyway, here, how does this work? The server basically, as part of the login form, sends a nonce. Let me basically sort of do a little digest-like algorithm. We take the password, and we still want to use a salt. The username may make a good salt. So take username, password, hash it, append the nonce, hash it again, pass it back to the server. So now the server receives a different string each time, so even if someone observes the traffic, they shouldn't be able to log in with it. They still need that admin access to the server to log in, to retrieve the hash from the database. And that attack still works. Now, if the user wants to change their password, then of course we forgo the nonce. We just want the hash, username, password. That hash is what you're entering in our database. It's really fairly easy to implement this. It all requires a little bit JavaScript in your application. And all of this happens on the client. It's also relatively easy to fall back. The way I've implemented this is where you have sort of two password fields, one for the hashed password, one for the clear text password. Now, if the user does not understand JavaScript, I get the clear text password. If the user understands JavaScript, then the password is hashed and the clear text password is cleared out, so I don't get the clear text password. I still have users for my sites that don't like JavaScript and keep it turned off, so still have to be a little bit backward compatible here Not sure how much that's true for your users, but I actually find that even security-aware users, they install like NoScript and all these plugins, and they feel very, very secure, and then like whitelist everything. And once you whitelist Google, then you whitelisted the world. So anyway, so the big advantage here is the server, and with that, the administrator of the server never knows the real password. Even if you hash your password in a database, typically the application still knows the clear text password. And this is kind of what you're trying to avoid here. So anyway, the client hashes everything. The password is never transmitted. You should still do it over SSL. This doesn't really say, hey, don't do SSL, but it still works. Another way where you could use this kind of technique is in some web services, or sort of AJAX applications, where part of the message that you send to the web service, you encrypt, for example, using a public key. Think, for example, things like payment card processing and such, where the server could push a public key to the client that's then being used to just encrypt the sensitive data. And then only the payment web service is able to decrypt that part of the data. And that way, sort of any intermediate web service, you do anything like service-oriented architecture, you have these messages being forwarded back to infrastructure, only the one component actually needs it, and will be able to decrypt this data. And all on the client works really well. Now, a quick summary before I switch to the demos is, like HTML5, and particularly in security circles, it's a lot sort of vilified. Hey, it's bad, it's insecure. It's insecure for the user. It breaks the user's browser, adds new vulnerabilities to the user's browser. You can help the user. By you not using HTML5, you're not making the user's browser more secure. They are still using bad video decoders and such that they got with HTML5 that are now being exploited by all these other funny kitten pages and such they go to. In the end, try to take advantage of what the browser has to offer. And like I said, understand user behavior. That's probably one of the biggest problems I see in security circles, not so much developers usually, but in particular network security. Hey, I use a 32-character random password. Why can't anybody else? And I change it every day. Test this stuff out. Like I mentioned, the pattern part. Sounds like a great idea, but once you have real users draw these circles and smiley faces, you find out they sort of fall into the same patterns. Because you still have that problem that passwords have. You have to find something that's easy to remember. That's the #1 criteria in picking a password. It's not making it hard to crack. You want to be able to remember the password. Now, let me see if I can get the other site here working. A little bit hit and miss here with the buttons, so maybe I'll get another blue screen. Come on. Good, something works. Okay. If I can get it all on one screen. So here, first of all, the connect the dots kind of thing. You first enter your name. I give the user the option to sort of pick how many dots they want, so they can adapt that to the size of their finger and the size of their device to make that kind of work. And then as you throw over here, also for debugging purposes, I have these little dots that show you where I move the mouse. You can then sort of draw a pattern here, and something random. And then once you sign up, it will show you what's the pattern. This is actually the pattern here that's now being transmitted to the server. It does include the sequence in which you hit the dots. So this way, if you would like, do 2 circles in one place, you get the 2 circles. You don't just get the 4 dots. That way, you get a little bit more entropy there, if you want to call it this way, to be able to distinguish different users. And then you have the client-side password hashing. Actually, let me just show you the code for that. It's probably more telling. I haven't shown any codes yet, and I always hate not to show code. But it's pretty straightforward. And here, this is sort of the login form. I basically have my username field, my password field. I have this hidden crypto password field, and I have the hidden nonce field, and that's populated by the server. And then as I submit it, I call this password hash function here, which then will go ahead and hash the password and clear out the clear text password. So the clear text password is no longer submitted. And I wrote it here so you can basically write your own hashing function. I didn't do this here yet for the demo purpose. I wanted you to see what's sort of happening there behind the scenes. So here it basically concatenates the salt and the string. Now if I use this form, let me go back here. Let's just log in. No, I don't want to save this password. So this is essentially what the server receives. It's the username and then this hash. Like I said, in this case, I just concatenated to sort of simulate a hash and make it easier to debug it. And that's the only thing the server would receive for the sign-up phase. For the actual login, you then also get the nonce. So if there's no nonce, then it's just the sign-up part, or the change the password part. So this is kind of a little demo I want to show here. All this code, if you want it, the site I put it on is here, authonthemove.com. There's a GitHub repository that's linked to it. If anybody has any other ideas, let me know, and let's put together some little libraries there. Let's be really fancy. And let's go back here. Yeah, it actually worked. So here I have the URL again, my email address too, if anybody wants to send me, but it's also on that website. Any questions? Yes, sir. Yep. The question here was, why not basically have the browser remember the credit card data versus the data being on the server? I don't think the credit card data should be on the server. I think there should be a token on the server that the server negotiated with its payment provider. That's really how credit cards should be dealt with. The problem with credit cards is that the site you buy stuff from has to know what your credit card is to be able to charge it. So you have to send that credit card somehow. Now, I feel better about it being stored in the sense there is some token stored on the server, so I don't have to send it over and over again. Of course, as a user, I don't know how they stored the credit card number. I once had an interesting experience with actually where I thought they probably did it right. AT&T cell phone. I had a cell phone account with AT&T, and my credit card got stolen yet again. And I got a new credit card, and I never had to change my credit card number with AT&T. They were still able to charge my credit card. Not sure how they did it. Like it was one of those things where they just give me the last 4 digits were different. And I assume they got some kind of token from some payment processor, but it worked. And I thought that's pretty cool, yeah? And they stopped billing once I canceled the account, which was good too. Yeah? But I didn't change the account. But yeah, so I think the credit card's a little bit slightly different there. Yeah? Yes, sir. Yeah, risks around WebSockets. I didn't mention WebSockets because I don't really think they have a big sort of security impact. WebSockets really sort of allow for this more interactive connection to a service. I don't think the current implementations of WebSockets are too terribly bad. Now, it doesn't mean that as a developer you can't abuse it. But they have this simple sort of key authentication setup where my browser first checks whether or not it's allowed to connect to this particular service. Some of the early implementations sort of got a bad rep and sort of poisoned a little bit that WebSocket feature because they sort of didn't do that check right, and you were able to connect, for example, to a mail server or such with WebSockets. The newer implementations shouldn't really have this problem. I don't think there's a big risk in you using WebSockets. Again, it's more risk for the browser supporting the feature. Yes, sir. Yeah.
Do you see this progressing to using proper public key authentication?
The question here is, passwords are broken, we sort of all agree. Are proper public keys a better way of doing it? Probably yes. Now, the problem with public keys is how do you actually hand them out? So there has to be still some enrollment procedure. But I can see it sort of a little bit back to your question with the local storage and such, where I just store this public key or private key in my client and have a different private key. Like you still need a different private key for each site you connect to.
Or maybe you use software HSM.
Yeah, a software HSM, host-based security module, something like this would be a nice thing to have. I keep playing around with these little, like they have these Android TV modules, whether this can be turned to an HSM. I think no stuff that's USB connected, read-only. That would be sort of a nice little hack. Maybe one of these days I'll get around to it or just run with it and take the idea and publish it. But anyway, any other questions? Yeah. Yeah, so the question is, using something like a nonce that's then stored on the client, yes. That's sort of a little bit that ever cookie. So the 1.5-factor authentication, where first time user logs in, you store something in the browser that will then be sent back the next time the user logs in, yes. We see some interesting work with that, actually not HTML5, using the E tag, the caching header. Where when you log in, I give you a specific E tag in the response. So when you log in again, I send you the same E tag back, and I can now check if you have that page cached or not. The nice thing here is it's sort of transparent to any proxies that are in between. It doesn't require cookies. So, all the cookie exploits don't really work against it. It's still a little bit experimental. I've seen some research papers that look promising, but not 100% sure how well it works in real life. That's always, of course, the question. I have 2 minutes. Question here is, how do you guarantee there's no tampering? You don't. But again, think about the threat you're protecting against. You're protecting against the server-side threat. You're trying to protect the client. If I can tamper with the client, then the unencrypted password is even worse. Yes, sir. Or does that answer the question? Or you look skeptical. Yeah. Well, with the private key example, that crypto, you would only send the public key to the client. Like if you want to encrypt credit cards or things like that. One more.
If you're protecting against server threats with your client
good problem here. How do you protect the code from being altered? You don't with this method. This method doesn't protect you here. SSL sort of protects you from it being tampered in transit, if SSL works well, but on the client you would need other controls to actually monitor that. So on the server, Okay, are we done? Okay. If anybody has any more questions, let me know. I do have some Internet Storm Center stickers and some business cards here. I'll leave out in the front if anybody wants some.